Hello everyone, my name is Arun and I'm back with another video, and today we have something very interesting. So what do we have? Well, we have covered lots of data in previous few videos, and today we are going to choose the Azure Data Services or data store, correct data store for a particular scenario. So what do we have? We have scenarios for you. We'll go through the scenario, their description, and we'll wait for the correct answer of the choice of data store that we can think of with some certain key points or from the scenario, of course. So let's start. So this is the very first scenario where it says real-time inventory management for a large retail chain. That's the scenario. So how it will work? That's explained in this description. A multinational retail chain needs a system to track inventory across thousands of stores in real time. Every time an item is sold or restocked, the inventory count needs to be updated instantly. And the system should be able to handle millions of transactions per day. Now, this is the description. That's our scenario. What do you think would be the best choice of data store for this kind of situation? Well, you can think in your mind, put it in your heart, or write somewhere. But what I think, given the structure nature of inventory data like product ID, quantity, store location, and the importance of maintaining consistent and accurate records. Remember ACID properties? So RDBMS would be a good choice. If we talk about Azure, it's Azure SQL database, Postgres, Azure MySQL that provides ACID guarantees, ensuring data accuracy. Could be a good choice. Let's go with the social media analytics platform this time. And it says a startup is developing a platform that analyzes user sentiments across various social media platforms. They need to process unstructured data such as tweets, status updates, images, and even emojis to gauge public sentiment on trending topics. If this is the situation, a social media analytics platform, so what could you think for the data store? Well, two things. It's unstructured. We can see tweet status, updates, images, a lot of various kind of structure. Unstructured nature of social media post, combined with the variety of data formats like text, images, links, uh, makes document stores like Azure Cosmos DB or MongoDB model a good fit, good choice. These databases offer flexibility in terms of schema and can scale horizontally to accommodate large volume of diverse data. Very well, let's go to the another scenario then. An online video streaming service wants to recommend shows to users based on their viewing habits and the habits of others who watch similar content. The service aims to map and analyze complex relationship between user preferences. Well, we have read about it. It clearly says recommendation engine. How? Through the relationship. So I'm pretty sure you're thinking what I'm thinking. The graph database. The core requirement is understanding, analyzing relationships. So of course, graph database, we showed you the snippet as well. It's all arrows, node, and edges, showing and representing the relationships and finding out the relationships again. So graph database like Azure Cosmos DB, graph data model. Now, let's see another one. A manufacturing company has outfitted its machinery with sensors that emit data every second. The data includes temperature readings, operational status, error codes, and more. The company needs to store this high volume time series data efficiently and analyze it for patterns, anomalies, or trends. Well, time series is the key here, is a little tip there. So in this scenario of large scale sensor data from industrial machines, what do you think would be the best choice? I gave you the hint. Well, If I have to do the reasoning, time series data often benefits from columnar storage because of its nature. Systems like Cassandra or Azure Cosmos DB column family data model allow for efficient writes and reads on timestamp data. This enables faster analytics and queries on specific columns, like all temperature readings over a month. A little tip here: wherever you see time series highlighted, always go for the column. It is meant for such kind of data. All right, let's jump on the another scenarios. I got plenty for you, just to cement that knowledge that we covered in few videos. So a job portal. A job portal allows users to search for jobs across the world using various filters, keywords, company names, or even phrases from job descriptions. The portal contains millions of job listings with new ones being added daily. Well, I think I need not to pressure much because the answer is hidden in the scenario. Global job portal with advanced search capabilities. I'm pretty sure you got it. The primary user action is searching, which requires full text search capabilities across large data sets. Databases like Elasticsearch or Azure Cognitive Search are designed for such purposes. Now, let's jump for hospital patient records management. A large hospital network wishes to digitize and manage patient records, including patient personal details, medical histories, prescriptions, and appointment schedules. It's crucial to maintain data accuracy and ensure the records are constantly updated across various departments. Now, such thing we have already covered. The key points that I could pick here is consistent data accuracy, structure kind of data. So with structured data that needs consistent relationships, what is the choice? RDBMS, like Oracle or Azure SQL, MySQL, which ensures data integrity and can manage complex queries related to patient care. All right, let's jump to another scenario, which is an airline. An airline company is developing a flight booking system where users can search for flights, book seats, and manage their itineraries. The system should maintain real-time seat availability, passenger list, and flight schedules. Now, I hope all of us have done that, like book the ticket to a flight. Now it's time to think about the database that they are using. And of course, with these similar hints, you can understand the structure nature of flight data coupled with the need to maintain consistent relationships. Again, RDBMS could be a good choice for such scenarios. It can handle transactions, ensuring that seat bookings are processed accurately and can support joins and complex queries necessary for such systems. All right, so next one is a mobile application allows users to keep personal journals. User can add text entries, photos, voice notes, and even location tags to their journal entries, and each user's data structure might differ. So that simply means it's not structured. All right, so what could be the choice of database? Well, given the flexible nature of journal entries and the potential variability among users, a document store like Azure Cosmos Mongo can accommodate such diverse data structures without needing a fixed schema. Another one is a system that stores configurations for various software applications. Each application can have different configuration settings and parameters that can be frequently updated. Configuration management system for software application. That's what we are thinking a data store for. So schemaless nature of document databases make them adaptable for managing configurations that may differ widely between applications. Document store could be a good choice. Now, a platform where professionals can connect, endorse skills, and be introduced to others through mutual connections. So seems familiar. The platform wants to suggest new connections based on mutual acquaintance or similar professional backgrounds. It seems like pretty much LinkedIn to me. So now you have a choice what maybe LinkedIn using that kind of database for such scenarios. Well, you can easily guess what the database or data store would be because the platform revolves around relationships. And for relationships, it's graph database like Azure Cosmos DB's graph model can effectively represent query these professional connections, making recommendations based on established network patterns. All right, let's see another scenario there. A tool used by software developers to visualize and manage dependencies between different software modules or components. Developers want to ensure that changes in one module won't adversely affect others. Now, think dependency management in software development. See what actually is happening. Dependency. Why? Because there is some kind of relationship there, right? Software dependencies are inherently graph-like. You can understand even if you close your eyes and think dependency means there is kind of relationship. This depends on that. A graph database can easily represent which components depend on others, allowing developers to analyze the impact of changes and potential cascading effects. Very good. We have seen a smart city initiative deploys sensors at every traffic light and major intersection, collecting data on vehicle flow, waiting times, and even pedestrian movement. This data helps in real-time traffic management and urban planning. What could be the best choice for smart city traffic management? Well, if you were listening in the previous few scenarios I talked about, the continuous stream of time-stamped sensor data can be effectively stored and queried using columnar storage system like Cassandra or Azure Cosmos DB for Cassandra model. These databases can manage large volumes of time streams data and providing insights into traffic to the another one, which is an e-commerce. An e-commerce giant wants to analyze customer behavior such as click patterns, time spent on product pages, and purchase trees. They aim to enhance their marketing strategies based on these insights. Now, if you see it closely, analyzing specific attributes of customer behavior over very time frames is more efficient with a columnar setup, right? Again, it is going with the timestamp, so you can easily choose the column database, which allows fast analytics on a specific behaviors, helping in driving actionable insights. Now, we have online recipe platform wanting us to choose the database for it. A platform where users can search for recipes based on ingredients they have, cooking time, cuisine time, and even specific dietary needs. The platform hosts millions of recipes from various contributors. With a vast amount of text, data, think what could be the best choice. With a vast amount of text data and the need for sophisticated search capabilities like finding recipes that match multiple criteria, search engine databases like Elasticsearch or Azure Cognitive Search can index the recipes efficiently, delivering fast and relevant search results to users. So there your choice. Search engine database. There are not many remains. I hope you're not getting bored. It's interesting scenarios though. A digital archive. Think about a digital archive for legal professionals, storing decades worth of case files, legal journals, court rulings, and more. Users should be able to find specific documents or references based on intricate search queries. Again, you can easily guess search queries, right? Search engine database could be a good choice here because legal professionals often need to search based on specific phrases, case reference, or even obscure legal terms. A search engine database optimized for this kind of text-heavy, complex search requirement, ensuring professionals find the exact documents they need. So another one is, again, e-commerce site with millions of concurrent users needs to keep track of individual user sessions. When users log in, add items to their cart, change preferences, etc., the system must save and retrieve this information rapidly. Now, you can easily think User sessions can be uniquely identified using session IDs. The associated data, like cart items, user preferences, becomes the value. Key value stores such as Redis or Azure Cache for Redis offer incredibly fast read-write operations suitable for this purpose. Key value data store could be a good choice here. Now let's see another scenario where a popular mobile game allows players to pause and resume their games across different devices. Again, you see, if you just think little deeper, mobile game allows player to pause and resume their game across different devices. The game needs to save the state, so players can pick up where they left off, not laid off, sorry. The player's unique ID or username can act as a key, and the game state becomes the value. So key value could be a good choice here. Now, a platform where users can upload, view, and share videos of varying lengths, resolution, and formats. The platform should support a vast amount of data and ensure smooth streaming of viewers. So we need a solution for video hosting platform hosting. Well, videos are unstructured data and their sizes can vary greatly. Blob storage service like Azure Blob Storage are designed to store such large unstructured data and can seamlessly integrate with CDNs for efficient video streaming. A good one, a very good scenario here. Now, let's see what we got. We got museum here. A museum wants to create a digital archive for its artifacts, which includes high resolution images, 3D scans, audio description, and detailed textual documents about each artifact. Think, well, the diverse data types and large file sizes makes object storage like Azure Blob. If you're coming from Amazon, it's S3. They can handle the variety of unstructured data and ensure durability and accessibility. Very good, very good. Now, e-commerce sales trend analysis. So an e-commerce company wants to analyze sales trends, understand customer buying pattern, and predict future sales. They need to process large volumes of historical sales data, product data, and customer reviews. Think for a database so that they can analyze. Well, data warehouses like Azure Synapse Analytics or Amazon Redshift uh, could be a good choice because they are optimized for analytical processing. They can handle large data sets, perform complex queries, and support tools that visualize and interpret data trends. Let's see what we have, or is it done? I hope it's done. This is the last scenario for us. A company is launching a new product and wants to gauge real-time public sentiment by analyzing social media posts, comments, and mention. So, analyzing data in real time requires platform that can process streaming data. It's happening real time. So, and it's a data which is streaming. Here is hiding your tip. Systems like Azure Stream Analytics can ingest real time data, analyze it on the fly, and provide immediate insights into the public sentiment. Well, with this, we have covered almost, I don't know, like so many scenarios with so many data stores. We have choice for each at least more than once. So the choice of data storage and processing platforms is often determined by the specific needs of the scenario that we try to highlight during the scenarios, the nature of data involved, and the required performance scalability are certain characteristics that we need to keep in mind. Well, availability, durability, and these other things will come for the solutioning purpose. But at the beginning, where we need to think the kind of data we have, the kind of performance we need, the structure, which will help us to determine the data store. And I hope these scenarios will help you to make a right choice or at least put it on the table. Well, thank you. And I hope this helps you and this is informative for you all. Well, thank you for watching and you guys have a wonderful day.